Well, hello everybody. This is Austin Buckles. I'm the sales manager over at DB Sales. And thank you very much for attending another DB Sales presentation of our weekly webinars, which we have every week on Thursday at noon. This week's presentation will be on the benefits of UL factory-built grease duct. Our guest speakers today are Keith Page and Dan Brown from AMPCO. If you do have any questions about the presentation as we proceed, feel free to write those in the questions and answers box, and one of our panelists will answer it, and we'll possibly answer it live if we have time moving forward. But with that, I will pass this along to Keith to get the presentation started. Thank you very much.
Thank you, everybody. So let's move on here. Okay, so hopefully everyone can see my screen. And we're going to just basically get into the benefits of factory-built grease duct. Done this presentation a few times over the course of years. And so anyway, but we're glad to be able to do this a little more locally for DB Sales. And obviously we can have further conversations, design help, whatever, as time progresses on. So as Austin said, we'll have some Q&A at the end, and hopefully we can address that, some of those live. If not, they can gather up the questions, I believe, and I can answer them separately in an email in the following week. As necessary, or even have a phone discussion. So, okay, moving on here. So what we're going to do, what is grease duct? I'm not going to take that for granted that everyone has familiarity with grease duct. What are the codes and standards related to grease duct? Testing and certification standards, and the benefits of factory-built round systems, and then the Q&A. So, grease duct in general, as we relate this to commercial grease duct, type 1 commercial kitchen hood exhaust. So that's what these ducts are connecting to. Basically a broiler, fryer, griddle, anything that is a cooking surface emitting fat, grease-laden vapors, or smoke. And so that duct work has to be connected to these hoods, and there's a couple ways of going about doing that. Another thing to bring up is the use of solid fuel cooking. That has garnered some popularity over the latter decade in all regards, and probably more specifically to the element of a wood-fired pizza oven. And so those keep popping up all over the place. And usually when it comes to those, the UL testing agencies usually end up trying to steer these OEMs that make these pizza ovens to get themselves listed to accommodate for grease duct, or to be listed for use with grease duct, instead of just, in the past, it was a lot of just the regular old classic twist lock chimney systems. And so now UL and other agencies, not just UL, have really tried to steer these OEM pizza guys to start using more grease duct listing. And some of that reason is because of the benefit of a grease duct, a factory-built grease duct, and the fact that a grease duct also is a chimney. So most of our, as you'll see as we go through the program here, most of these factory-built grease ducts are actually started out as a all-fuel chimney system. So it's kind of killing two birds with one stone, and you get the benefits of a grease duct layout and such. So keeping that in mind as you go, any of you approach pizza oven venting, that you want to kind of steer towards the factory-built grease duct side of things. So as far as the safety codes go, I know I'm speaking pretty much to California here, as far as I know. So you guys typically reside on the Uniform Mechanical Code, which usually mirrors the NFPA 96. And I know you're on the California Mechanical Code, but a lot of that language basically stems from Uniform Mechanical Code, UMC, and then also, for the most part, is reflective of what NFPA 96 says. Now, much of the other part of the nation is on the IMC, International Mechanical Code, but and so each has their own uniqueness when it comes to grease duct. I'll try to spell some of that out as much as I can, but by and large, you're dealing with a safe, much safer product. So, what are the material requirements? As far as field fabricated methods go, 16 gauge carbon steel or 18 gauge stainless steel is what can be field welded or sheet metal shop welded duct, liquid tight welded duct. Or you have the option for UL 1978 factory built, listed factory built duct, requiring a stainless steel inner wall on that. Now that can be allowed to be lighter gauge, as you'll see some of our, part of our construction method is a lighter gauge material, but because it's gone through that UL listing, I'm allowed to be lighter gauge stainless. Then we get into hourly fire rated grease duct enclosures, when those are required. So you've got the traditional construction, shaft construction, I'm talking gypsum shaft type style, as per the building code. And then the relative duct clearances inside that enclosure shaft. Sometimes that comes into whether the shaft is non-combustible or limited combustible or combustible. So all kinds of goes into the definition of the shaft construction per each code. And then you've got the flexible insulated aluminum foil faced wraps. Those are your AKA fire wraps. 3M is a very popular one out there. There's also I think there's a fast wrap out there, a Fire Master, and I sometimes get the names mixed up on those, but basically they're the grease duct wraps. And then you have, and that goes around, those wraps get put around welded steel, field fabricated welded steel ducts. So, and then you have the integral factory built enclosures. So the factory built systems are pretty much a double wall system. Most of them are 3-inch insulated or 4-inch insulated double wall. And then they have usually a metal outer jacket as well. So take note of my little snippet on the right there, fire dampers not allowed in grease duct. So that's where these hourly rated ducts come into play, basically because contrary to air duct, you can't really have fire dampers put into these systems. So access door cleaning. So this is where you get some differentiation between the code bodies, whether or not you're NFPA, UMC, CMC, or the IMC. Most speak to a one access door requirement of said size there, 20 by 20, or sometimes it's a 20 by 22 for personal entry. And then it says if that personal entry size can't be accommodated, then they want the spacing at 12-foot intervals for NFPA UMC or 20-foot spacing for the IMC. And then usually within a 10-foot distance from a 45-degree change in direction. So, and that's either side of that 45-degree change. And then every floor vertically, again, if no personal entry is accommodated. So if you've got a smaller duct, and that's again tying back to NFPA guidelines. So that one comes up quite a bit in question. Do I need it or don't I need it for the floors? I would contend, honestly, that one, if the duct is large enough for the ability to so if you got call it a 20-inch diameter duct or larger, or 22-inch diameter, whatever, however dotted I's, crossed T's you want to be. But to me, that is fine, assuming you've got cleaning ability from the top of the stack riser and cleaning ability from the bottom of the stack riser. There's really not going to be much buildup in round stainless duct, for that matter, from a practical perspective. And putting in the access doors every floor, if you say you had a smaller duct diameter, can get pretty tedious in my mind. The reality of if they're ever going to get used on every floor is up for debate. Depending upon how tall the stack is, duct riser stack is, maybe there's a merit to have one spaced out a much broader scope just from a practical reason. But one of those things that can add a lot of cost to a system, in my mind, unnecessarily, all because of how codes interpreted or applied. So, okay, moving on from that, clearance to combustibles where enclosures are not required. So 18 inches is your standard default clearance for single wall ducting, whether that's field welded or factory built single wall duct. We do offer that as well. And by the way, our factory built single wall duct actually can use a flexible wrap if somebody wants to do that as well. So we do offer that as an option, wrap third-party provided, but that can be applied to factory-built round single-wall duct. So just like it does with the field welded rectangular. And then we have some traditional double-wall models that are not fire rated. Like a 1-inch blanket double wall model, a 2-inch blanket double wall model. Those have reduced clearances from the 18 to combustibles. So slope. So this is a great benefit of round duct as compared to anything that's flat bottom, whether that's oval or square flat bottom. All your round factory built duct out there, by and large, is at a 1/16 of an inch per foot slope. So that is, and that is our UL listing. The codes do allow for it as an exception. UNFPA 96 states that. I believe the current UMC also allows for that. I don't know where the states are caught up on those or not, and then I know even the IMC is going to be including that in the next revision there. So, and so when you compare that to traditional flat bottom ductwork, i.e. rectangular or even oval flat, those are still supposed to be at a 1/4 inch per foot for up to 75 feet. And then a big jump to 1 inch per foot slope for greater than 75 feet. So ours is round goes to 3/16 of an inch per foot for greater than 75 feet. So a lot of headroom ability saved with round duct. And we'll talk about that a little bit later for those particular situations. But yeah, grease duct leakage testing, field testing validation. So by and large, the light test is still what's out there as far as being enforced. Really doesn't get you anywhere on factory built systems. The joint method, or the joints are banded and caulked, and that's about it. So there's a water washdown test option as well, and that's really honestly the most practical in my mind. So if anybody does ask me as far as what do we do to validate this, as far as the installer that the installer did everything correctly, short of validating that they did caulk the joints, and that other items were put in properly. To me, a water washdown test is it, and especially in the rough end phase, because by and large, the food operation is going to have future restaurant cleaning anyways, and most likely with water washdown. So if you've got any potential issues, whether that was a manufacturing issue that got delivered to the job site, or whether it was installation issue, much better situation to rectify that during the construction phase, rough end phase, than to experience that when the duct cleaners are in there, 6 months later, while the restaurant is operating. So that's my vote for that. But again, the light test is still probably the prominent method of test that's enforced. So air velocity, 500 feet per minimum is kind of what the language is now. That's minimum. So that does allow for a lot of retrofit situations to go that slow. Typical design is 1,500 to 1,800 feet per minute via ASHRAE. At one point in time, the UMC had language in there up to 2,500 feet per minute maximum, but I think that got removed. I haven't seen that since, at least what I've been able to find. But so I think that was moved. But I just wanted to bring that up, that it had been in there in the past. So really, your 1,500 to 1,800 feet per minute is kind of your design target as far as what typical ASHRAE methods are doing. So The codes speak to termination, fan locations as well, installation requirements, and then there's a whole list of other criteria that speak to the grease duct section. So field welded duct. So as far as getting into the testing standards here, so there's really no third-party testing when it comes to rectangular grease duct. It's just the minimum code requirement, as stated previously. 16 gauge carbon steel is, 95% of what's probably used out there when it comes to field welded systems. So, and then it's a liquid tight welding, and then, but that's it. So the only thing that's really tested is the fire wraps, insulation wraps. So now those are applied to the duct work when they are tested, but we'll see here some I call it limitations that aren't necessarily apples to apples when it compares to factory built systems. So ASTME 2336, that's your field applied enclosure systems, the wraps. And then factory built grease ducts are UL 1978 baseline listing, and then a UL 2221 for the fire resistive fire rated enclosure of that. So you have to have any grease duct factory built wise has to have the baseline listing of UL 1978, and that's where all of our traditional models have that, from single wall to a variety of the double walls. And then the UL 2221, we have just really two models that have that as an additional listing. So I do want to point out on my one bullet point there, beware of manufacturers that say comply or claim a partial listing. There have been a few out there that use the word comply. They don't necessarily bear a logo of the listing agency, and they really should say the word listed. So compliance is really not valid, and some will even just say complies with chapter such and such of UL 1978 or section 13 of UL 1978, something like that. So that's really a bunk listing or claim to have a certification. You're either all in or out as far as it goes with UL 1978. So there's no halvesies or anything like that to be had. And go from there. So, and again, the ability of any given manufacturer to show the logo of UL or another test agency as far as listed with that testing agency, I mean, that there gives the ability to say that they tested to the standard. Now, even though they're UL standards, there are other test agencies that can use the UL standard, and they just can't. They'd have to show that listing agency's logo instead of UL's logo. So we usually gravitate to UL as far as being the authors of the standard, and also as the test lab listing agency has kind of been our preference, and for quite a few reasons. So overview, ASTME 2336 wrap enclosures. So they go through some tests, non-combustibility tests, fire resistance test, durability of insulation wraps. I'm not going to get into the details of these. It does do an internal test, so they do a 500 degree continuous long-term test, and then they do a 2000 degree 30-minute flare-up test. And then you're getting your zero clearance to combustibles on that. And then what's really, we'll take note here, permits up to 10 seconds of total flaming at a joint or seam of a wrap enclosure. So scratching my head on that one a little bit, but it does allow for that, so that you could actually have a flame propagate from a joint for 10 seconds. I'm not saying that the wraps, any given situation does do that, but that's where I'm going, where some of these tests they're not as apples to apples when it comes to the factory built systems and what they endure. So, and this probably in my mind gets to the point of the construction of the welded steel systems and the ability to really endure those severe tests, the 2000 degree 30-minute test, and we'll see some other pictures of that. So, and then there's a fire engulfment test, again using code constructed steel duct. You got your wrap, and then you're establishing your 2-hour fire rating and fire stop system. UL 1978 factory built test. So there's a whole materials testing situation there, requiring stainless steel, as I said earlier. Multiple mechanical strength and loading tests. So basically the duct integrity by itself, whether it's wind loading, self-supporting the systems, all that stuff, as well as going through the 500-degree long-term or continuous test, and then 2,000 degrees at 30 minutes, severe grease fire. So we're establishing on all of the models, this establishes the reduced clearance to combustibles for all the double wall models. And again, that's where enclosures are not required. Fire-rated enclosures aren't required. And then you've got grease duct leakage test, access door test, and then UL inspections, quarterly UL inspections at the factory. So, and then regrouping back a little bit on that solid fuel comment I had earlier, NFPA requires UL listed duct for any buildings 4 stories or higher. So that's kind of an NFPA language that's come in the latter years for higher story buildings, that they are strongly, well, I guess in theory would be enforced for UL listed grease duct for solid fuel appliances. And again, that gets back to the fact that these UL listed ducts are both an all fuel chimney and a grease duct. So it's kind of a 2-for-1 there. UL 2221, the testing for that, the fire rating side of it, so again, requires you to have a baseline listing of UL 1978. Again, goes through multiple insulation, durability, property tests. Internal fire test, again, 500 degrees, 2,000 degrees at 30 minutes. Now, the location of the thermocouples are at slightly different points, where it makes UL 2221 a little bit more severe on the internal temperature tests as compared to 1978. But in this one, you're establishing a zero clearance to combustibles, no ignition of dry cotton at any openings and enclosures. So remember that 10-second flaming propagation that was allowed for the wraps. This one here, if there is an opening even in the outer wall, so let's say the outer wall, you get a little bit of a separation there during and usually if that were to happen during the 2,000 degree test, they put a dry cotton swab, desiccated dry cotton swab in that opening to make sure it doesn't self-ignite. So, and then we've got the further restriction of there's a maximum 25% cross-sectional reduction after the thermal test. This is not a requirement in the wraps on the rectangular welded steel duct. So we are held to, now you'll see pictures later on that we don't even reduce in size or reduce in cross-sectional area, but there is a limit that is set in place. We don't have that, or the wraps do not have that limit at all. Of any sort. So they're allowed to, in theory, they're allowed to collapse in that regard. Fire engulfment, similar thing here. Duct integrity, again, we have the maximum cross-sectional reduction requirement during the fire engulfment test, and then that's establishing our 2-hour FNT rating and fire stop system, and then of course the factory inspections. Getting into the construction of this, welded stainless steel tubes, flanged ends, very robust connection.
I apologize for interrupting you there. We have a quick question, I think, in regards to that last slides for clarification. They were, Matthew was asking for if that is in regards to a 4-story building or a 4-story of stack length.
I think it's 4 stories, 4-story building, and I happen to have NFPA book open here, and I will read it verbatim. It basically says, let's see. Yeah, a listed or approved grease duct system that is 4 stories in height or greater shall be provided for solid fuel cooking exhaust. Well, okay, so that grease duct system that is 4 stories in height or greater. So I guess that is a good clarification that I never picked up on that exact word there. How that gets interpreted by a code official, I'm not sure. if they look at the building or if they actually look at the way the grease duct system says. So to me, I read it as the grease duct system that is 4 stories in height or greater shall be provided for solid fuel cooking exhaust systems. So
That sounds like the stack.
Yeah, that's how I'm interpreting it too.
Okay.
And then it says in buildings where the duct, the beginning section on that area, in buildings where duct system is 3 stories or less in height, then it allows you to just comply with the basic duct construction if you want welded steel. So anyway, good question, and something I learned today that I didn't pick up on before. So,
very good. Thank you, Keith.
But yep. So moving on. So the construction of the grease duct here is really it really comes off the platform of our decades-long boiler flue and generator stack that's been out there, aka pressure stack at 1,000 degrees. So pretty much the same construction. Not sure how many of you have been familiar with these. These have been around for a long time as far as, classic boiler flue, the fire tube, water tube, big boilers, that type of stuff. And then even the generators, generator engine exhaust. So, and again, this stuff's been around since, this type of product's been around since the late 70s in their end. So, but 20 gauge inner wall stainless, 300 series stainless, flanged in there, the V-band connection. And then the outer wall is usually a 24 gauge aluminized steel or stainless steel. And then we actually have some decorative options that I'll speak to in a little bit. So joint connection, caulk the V-bands, you mate the pipes together, and then you pack insulation strips around the joint there, and then you've got your outer channel band that goes to that. So inner bands, what we call P600, and then the outer band is for weatherizing exterior pipes only for using the same stuff. So, and then with the single wall product, obviously you wouldn't have a double wall outer system or outer channel band. You would just basically have the inner wall part and the V-band clamp that goes with that. So wide variety of system components from beginning to end. Tees-wise, expansion joints, I underline that for a reason. Your welded steel systems don't have any accommodation for expansion, thermal expansion, especially if you were to get in an extreme fire situation, whereas we do have telescoping expansion joints to absorb some of that. And if you ever get into a higher heat application for that matter. So case in point, pizza ovens, wood-fired pizza ovens, those things usually are at around 800 degrees, 900 degrees cooking temperature. That's why they get done in about 90 seconds for some great pizza, but that's some high temp. So that factory built duct comes into play very good with that, because that can happen. That can have a lot of thermal movement when you're pushing those temperatures on a continuum. So access doors, support squared arounds, inline drains, if necessary, fan adapters, induct fire suppression. That's not as prominent, the induct fire suppression. There's really only a couple times it's come up, and maybe 1 or 2 jurisdictions that come to mind that require that, but we don't default put in induct fire suppression. So we do have the ability to do that if necessary. Usually it's an inline T that we would have an access door right there for it, and then we could put a nozzle, some type of nozzle section, plumbing pipe type thing welded to our inner wall, whatever's needed to accommodate the fire suppression nozzle coming into it. So a couple pictures there. You got a starter hood, starter piece, hood transition there going off. Ideally, if there's enough coordination and the airflow is the CFM coming out of the hood, if you can get a round out, a lot of these hood guys can make a round collar now, and or we can even ship ahead a collar if necessary, so that it becomes a direct connect, and then you don't have these squared around situations. These can get costly. We do make them. We do also allow for the installer, local sheet metal, to make them as well, to transition ours. Either way, it doesn't matter. But it's a costly item no matter what. So these, if we can do a direct connect, again, I know there's limitations on the round collars based on the CFM coming off of any given hood. So there's that, but if that's the way to go for a direct connect if possible. So and that takes that element out of there. And then a fan adapter. It's hard of a picture there, but basically that just sits on top of the roof curb for an upblast fan anyways. So no tool access cap, kind of just a diagram there of that. Usually our T's usually we use 90 T's for the change in direction. We can use 90 elbows with inline access door before or after the 90 elbow. We can even make a 90 elbow with an access door integral to it. Usually that door is a lot smaller though, just based on the duct, the size of the 90 elbow. But most of the time we're using 90 T's. You know, they're still radiused on the inside, and then you get your change in direction clean out on those. So that's usually the least cost way to go on that method versus 90 elbows and inline access doors if necessary. So, and then that's the inline access door, the next screen there. It's just a 30-inch long pipe. And again, toolless, another toolless door removal thing. So modular system. So again, as you can see through the presentation, everything's installed in segments. You can even pre-assemble these into a stack on site. You know, booming into an inaccessible. Now this is showing into a chimney. This happens to be a boiler flue, but in essence, you could do the same thing with grease duct, going down an existing chimney. We had a job going recently, actually right now, where they're putting in, they're doing it in segments as well there. The installer came up with a rig to capture the pipe, and I think we're putting it in about 20-foot segments, putting the pipes together, the ducts together, and then he's dropping these down with his rigging equipment into the shaft that they're going in there. So, so a lot of, yeah.
This is Steve Mertz over at DB Sales. We got some more questions coming in from one of our consulting engineers. Is it all right if you maybe address this? He's had a couple here.
Okay.
Asking, do we need to provide the fire wrap 3M around the factory built grease duct per CMC?
No. The whole reverting back to the enclosure, we'll call it shaft enclosure requirement. The wraps are strictly for single wall duct, predominantly used on field welded single wall duct. As I said earlier, you can actually use the wraps on our single wall round duct if you want as well. But otherwise, for the most part, the double wall, and it happens to be our Z3 model, 3 inches of insulation, Zebra 3, that ends up being the shaft requirement. So there's not an additional wrap that you need to do for that. No. So,
and just to address some of his other questions, that Z material that Keith is speaking here, that is a 0 clearance to combustibles material. And that's available
correct.
3-inch insulation thickness and 4-inch insulation thickness. And that is a 0 clearance to combustibles.
Yep. And it's a 2-hour rated duct. So, yeah.
Sorry, it eliminates the need. Sorry, I was muted there. It eliminates the need for a separate shaft, correct?
Correct.
Yeah.
Yep. At that point, you would just need an aesthetic wall, unless you wanted to look at the ductwork. But you just need an aesthetic wall, and as you pass through your floors or walls, then we have an appropriate fire stop for that. So.
Great. Thank you. Thank you very much.
Okay. Continue on here. We have, so again, the booming side of things, pre-assembling some stuff on site. We can actually even pre-weld some pipes together at the factory. We've done this on some boiler flues a handful of times, probably anywhere from 10 to 15 foot long. We can actually pre-weld them together, and then that get shipped to site. Now, obviously, there's different freight handling requirements there, and a little more expense tied to doing that, but that has been done as well. So the ducts have gone through a seismic testing, kind of a shaker table test. That stuff was done a long time ago, actually, but the ductwork has gone through the rigors of a seismic shaker up to, I believe it was actually 10.0 on the Richter scale, where you had about, if I remember right off the top of my head, about 30 foot of stack. There was a guy, I think there was some a guy point at 20 foot, and then the pipe, shake, rattle, and rolled as it went there, but none of it ever came apart, disassembled, or whatever. So that is available. I'm not claiming that I'm a seismic designer of sorts and everything else. I can only offer up some data as much as I'm able to, but I will make that disclaimer. I'm not the seismic engineer on that stuff, so I can only offer up what I'm able to do on that. No field welding required, as I've stated so far. So there's really not, that takes away, especially on renovation retro jobs, the hazards that can be associated with welding on site, especially during a restaurant or something that's trying to operate still. And then multi-story situations too. You take away a fire watch that's usually required at the bottom. So again, the no welding requirement goes a long way too, especially on retro work. And then being a round duct, inherently you get some green buzzword energy efficiency out of it. Just in general, round duct can be up to 45% lower airflow than a very high aspect ratio rectangular duct. It's just general airflow characteristics there. So again, long-term fan energy utilization, lower operating costs. And then sizing for round grease duct is really much the same as you would for round air duct. I've got a pretty barbaric calculator that I can offer up as necessary. I end up having to use a generator calculator, but I can plug in CFM there. But and I have to do some other stuff, but I can give you some estimate of duct loss based on that if necessary. But by and large, you're just doing your round air duct is going to be the same principles. So stainless steel inner wall. So highlighting that a little bit more. I mean, stronger than carbon steel at higher temps. Inherent corrosion resistance, as you know. There was an incident in Vegas. Now I've heard this secondhand, but there was an incident in Vegas where the whole bottom side of the carbon steel duct that had been installed for whatever number of years basically rotted out, and they ended up having to replace the whole bottom side with stainless. So all the years of high use, probably very frequent detergent cleaning, and had they had they had the ability to use round stainless factory built systems. I don't know exactly when the original was installed, but had they used that, you wouldn't have ever had this issue, and that would have been a costly situation. So easier to clean. As I said earlier, grease is going to have a real hard time sticking to the round stainless. There's just not the corners, crevices to be had, and just the normal surface benefit that stainless provides versus a carbon steel. So some of the spin jet heads, those are little components on duct cleaning equipment that as they're turned on, the heads spin around as they're going into the ductwork, throwing water around and such. So, and then we had, again, another secondhand intel. There was a retro job in Texas, and they had swapped out the welded duct with factory built round, and in due time, they noticed that cleaning time went down from 3 days to 1 day for that. So just lower operational costs for the building owner long term. Multiple models. So looping back in with the variety that I was saying we offer, you've got 7 total models, single wall duct to heavily insulated double wall and fire rated zero clearance. So all these models are interchangeable on any given job. So the ID stays the same as you connect one size to the next, or excuse me, as you connect, if I had a 10-inch single wall duct and a 10-inch double wall duct, the ID stays the same. It's just the outer wall getting larger. And so every one of these is a UL listed 1978 duct. The baseline listing accepted by code. As I said earlier, the single wall duct can be used have a field applied wrap around it if you want it to. But otherwise, our Z3, Zebra 3, or Zebra 4 model is also a hourly rated duct. That's that 2221 I was talking about, the fire engulfment test. So that makes it, a shaft alternative, equivalent, so to speak, to the wraps that would be applied to welded steel duct. So some may ask, why do you offer a 4-inch if the 3-inch is fully compliant? Reason being, 4-inch occasionally, that's getting less and less and less as time goes on. But 4-inch legacy specs are out there still that we have to comply with. And truth be told, back in the early days of the Zebra 3, Zebra 4 models coming out in the early 2000s, there was some uncertainty as which way code language was going to go with regards to certifications and listings. So we made both options and tested them to their standards, and so that's why we have offered both since. But by and large, we promote the Zebra 3 model completely, 100%. It is fully code compliant, to my knowledge, coast to coast, at least at the national code levels, and for that matter, most of the state codes. But 4 inches available. Occasionally, you just get a specification that is what I want. Case in point, a couple years back, we had a specification come up. They wanted 18 gauge inner wall stainless. So again, not necessary. Our standard is 20 gauge. That's part of our listing. But the engineer was adamant on having 18 gauge stainless, which we can make. And he wanted the 4-inch model, so the Z4. So we offered it, we did it, sold it, and life goes on. But just making it clear that there is opportunities to put in a little lower cost item for that. So, but still achieving the same results.
Keith, we got another question in here.
Go ahead. Yep.
One of our engineers again. Just asking about the factory grease duct approved. Is it approved by the city of Los Angeles? I don't know.
So good question. Good question. Because it is written into code now, factory built systems, LA does not need to do an RR report anymore. So I've had that clarified 7 ways to sundown from the LA office about that. And because it's written into code, UL grease duct, basically, it is not, there's no necessity to have the RR reports anymore. So we used to long ago, before code language caught up with that. So,
yeah.
and that even translates even, I know you guys don't work with, maybe some engineers work in New York City, do jobs in New York City, maybe you don't. I know people work all over the country now, but regardless of where they live. But same thing with New York City, the MEA numbers. For those of you familiar with MEA numbers, same thing there. New York City code allows for UL grease ducts. So at that point, the MEA numbers were no longer necessary.
Thank you very much, Keith.
Yep. Factory built. So again, I've been talking about all these different models. I want to elaborate a little bit more on the value engineering options for these. I'd love to, my sales guy, Dan, and of course, DB sales, they love to sell Z3 all day, every day. It's obviously a more premium product than the other two, but from a practical engineering perspective, so sorry guys, but there is the ability to value engineer these things. And what I'm trying to get at ultimately is that the perceived notion that factory built systems are potentially way overpriced and everything else. We've got a lot of things in between, intermediate, that can be applied to help bring costs down if the building allows, but still you get all the benefits of round factory built grease duct. And that's what I'm trying to hit home here is every one of these models from single wall, round to all the double wall have the stainless steel inner wall. They're round, inherently stronger. The cleaning, less cleaning frequency, all that stuff, the lower slope requirement, all that stuff comes into that. So whereas your rectangular systems, field welded systems, there's no intermediates. It's single wall rectangular welded or 2-hour fire rated zero clearance duct wrap. That's it, and nothing in between. So what I'm trying to explain further is we've had, and I'll show here in a little bit, we've had jobs where Z3 has been purchased and installed, but when you really look at the job and the layout and the building surround, there was no need for it. A C1, a 1-inch blanket model or a 2-inch blanket model would have totally sufficed to fulfill the requirements of the building, the code, and still given the safety requirements as necessary. But what I think would happen, and us not getting a chance to help value engineer it, being down the food chain there, is basically, I think original specs were written around welded steel with fire wrap and zero clearance, because that's really all there was to offer, with the exception of just single wall rectangular welded. And so somebody proposes factory built, and automatically the thinking kicks right over to our Z3 model, because that's technically the equivalent, right? Neglecting or unknowingly not realizing that there's other models out there that give the same benefit. So what I'm trying to say is not all jobs require zero clearance or even a fire rated duct or shaft. I'll say, you know, there's a lot of jobs that don't have zero clearance requirement. The entire surrounding construction is block, brick, steel, whatever. There's nothing combustible in sight. The fire rated shaft situation, that, you know, that's going to depend on whether or not you break through a rated wall or floor as how the duct routes. So that might happen more frequently. But what, you know, that depending upon that job, you may not need that. So if you don't need the zero clearance and you don't need the fire rating side of it, the 2-hour fire rating, any one of our traditional models here will suit as a grease duct. And where I'm going with this is, even from a clearance standpoint, my IVSI C2 model, up to 16 inch, has a 1-inch clearance to the outer wall of the pipe. That's a 2-inch blanket model, 16 inch. So the working window is 22 inches. So 16 inch ID plus 2 inches of insulation puts me at 20-inch OD duct. And then I have a 1-inch clearance window, airspace clearance window around that. So 22-inch working window. And then if I do a 16-inch Z3 model at zero clearance, again, 16-inch ID, 3 inches of insulation, so that puts me at 22 inches, and then I have zero clearance, so it's 22 inches working window. So same working window, but the price point on C2 will be much more beneficial, favorable than a Z3 model would be. Just, you know, just reality. So again, just making sure people realize that every one of those models is out there. You can mix and match as the building requirements, environment needs. And then, you know, we put layouts out there. Many of you are probably aware of layouts that DB Sales has provided for boiler, flue, generator exhaust, or even grease duct systems, where we've got that schematic to help keep things sequential and straight. So I know sometimes it's just easier to go with zero clearance, and then it's quote unquote dummy proofed. I get that, totally reason with it, but just saying there's options. So for lower cost items. And as leading into that is this particular product here. Now this job was at a hotel, happened to be downtown New York City. This was all C2 model up in the ceiling space. Now, totally fine to use C2 up in here. There really wasn't any clearance issues. If there was, C2 we had enough clearance anyways. Because it is significantly reduced, even though it's not zero clearance, but it doesn't have a fire rating. Well, this did not pass through a rated, where it left the building. It went through I call it a ground floor ceiling or slab that went up the exterior of the high-rise hotel. So to my knowledge, it did not pass through a rated barrier, fire rated floor, because it immediately went outside and went up the side of the building. So a lot of money was saved for somebody using the C2 product versus kind of traditional default thinking using Z3, and especially outside the exterior of the building, which was again all brick facade. So up, and it happened to go 300 feet up. So money was saved on this particular option here using the non-fire rated C2 model and non-zero clearance. Yep. So getting into that, we're going to see another slide too elsewhere of that, but support spacing is often less than field welded. So these are our we'll kind of call the stack heights. Now I'm circling the Z3 model. Some of the stack heights here, and that requires just one support plate at the bottom and then some guide spacing, probably up to 20 or 30 feet. Usually it's about a 15 to 25 foot span on the spacing requirements for guide rings, but that's quite a bit of stack height, 100 foot, 70 foot, 55 feet of Z3 model ductwork that I can have with just one support plate at the bottom. That's framed up on 4 sides. So same kind of support plates that are used with generator exhaust and boiler stack. And then horizontal spacing anywhere from 12 foot, 10 foot, 7 foot for the Z3 model. So usually your wrapped and welded duct systems are probably every floor where they're holding on to support, and then support spacings on those are usually at 5 foot intervals. So moving into the Z3, a little bit of elaboration there. So one inspection for that, for a factory built system. Technically, field welded and wrap system is supposed to have 3 inspections. You got welding, and then you got each layer of wrap is supposed to be inspected. Whether or not that happens on the first layer, I don't know. But anyway, code official inspection, that's additional delays in a project in our world. So the aesthetics of factory built versus the foil faced, the integral hourly rated enclosure. We've got a 24 gauge metal outer wall versus a foil insulation wrap. You decide on which one's going to resist incidental trade contact during the construction. Let's see, moving on here. This is kind of a little bit of footprint. I know we're comparing square duct, but you've got a traditional gypsum shaft, 18 by 18 duct in there, 6-inch clearance to the inside, consumes about 12.25 square foot of space. You've got a 20-inch round duct, 26-inch OD, consumes about 3.5 foot of space, square foot of space. And then a field weld, again, 18 by 18 duct where you got a field wrap and welded duct, 2 1.5-inch layers of thick insulation. Some wraps still may require the butt or the overlap joints, which extends that footprint a little bit. I know some wraps also have a butt joint approval now, but I don't know if all of them do as of now. But again, similar footprint in my mind when you at least comparing an 18 by 18 duct. So most high-rise cities approve. So I was talking a little bit about New York City, and I did reconfirm that LA does approve as well. Combining carbon steel systems. So again, I realize there are going to be locations where it's just flat out impossible to put a round duct in there, even at shallow slope of a 1/16 of an inch. So you've got a very wide rectangular duct that's got to get put in there. So we do permit intermixing of that. We've got several jobs in the recent past that have had that done, where the horizontal was all done welded rectangular steel and wrapped, and then the vertical stack part was done with factory built systems. So we do permit it. We got a little section in our instruction manual that does permit it. So we've had jobs that go to and from and back to and all that too. So the CAD layouts, you guys many have probably seen those just from some of our other applications as well. And then you get a lifetime warranty on all the factory built models, and that's every one of them, even the single wall. So we provide a limited lifetime warranty on that. A couple jobs here where they start out with rectangular wrap systems and then transition to round. You can see the header there, the round duct in the back, and then the drops they did with rectangular. This one here was shallow, and then they transitioned to factory built round. Less slope requirement. Elaborated this on earlier, and I better hustle up with time here. So we spoke about it again, 1/4 inch per foot for flat bottom, 1 inch per foot for the for longer runs beyond 75 foot. And we're round bottom systems are 1/16 per foot, and then 3/16 for greater than 75 feet. So that's just it's a combination of testing, evaluation, and just normal hydraulic flow calculations. Well, now that comes into play on how that works with a round shape versus a flat bottom shape, and how liquids flow in those. So case in point here, 50 foot of horizontal duct, you got 3 1/8, about 3 inches of slope, whereas you got 12.5 inches for rectangular flat bottom. And then when you go 100 foot horizontal, significant jump there. So 1.5 to 8 foot, so to speak. So we can do seesaw approaches too. I know sometimes when you get to these really long runs, the rectangular ends up doing a seesaw approach to help mitigate just a continuous run. They do a seesaw up and down. We're able to do that too if necessary with the right fittings and access points at the bottom of the valley. So with all that said, look at this thing. Slope doesn't matter on this one. So this just puts credence to the fact that there will be systems out there that do not get maintained. Ton of grease on this thing built up over I don't know how many whatever timeline that was, I don't know. It's obviously sticking to the side and the ceiling, so at this point, slope doesn't even matter. But it is a real thing. I pity this fella, but I guess he's working, so that's good too. But cleaning this up, I think one of the other pictures I was given on this, the guy came out with just a big watermelon-sized mass of grease. So it's there, and that's a whole lot of fuel waiting, and that's going to rip roar through a ductwork and cause severe issue, and especially probably for a rectangular system for that amount of fuel. So, and that's where, again, that kind of gives credence to the 2,000 degrees for 30 minutes. Now, is every grease fire 2,000 degrees, 30 minutes? No, but if you have the right amount of fuel, it definitely could. Aesthetics, jumping into this quick, painted colors, we can do powder coat painted options right out of the factory. We can actually even do custom materials such as copper or polished steel, polished stainless steel, and we can do even do laser cut designs, logos, company names, and such. So that's all a custom type of option for anything that might be exposed to the public, or decorative, even if you just want a couple sections that are that way and the rest are standard. These are your typical looks of unpainted aluminized steel or the default unpolished stainless steel. Usually our stainless steel outers are what they call a 2B finish, and then the aluminized steel kind of looks like galvanized, but we can make that look better if necessary. If field painting is required, or field painting is part of the plan, you'd obviously would just get the aluminized steel, and that can be field painted. So this kind of just helps show some of the aesthetics, of course, exposed ductwork. So even the default stainless that we have is not too bad to look at. Don't get me wrong. Could have been better, maybe, but I want the other thing to point out on these two systems is the fact that they use Z3 model on these, and there was no requirement for that. Could have used a C1 model, saved a lot of money. Actually, probably would have been a smaller footprint, just because you're taking 2 inches out of it. But there was no combustibles issue to be had around there. There was no penetrating fire-rated walls or anything to have. So it just was default specs that originated as black iron welded with a fire wrap that then translated to factory built, that nobody bothered to check if there was lower cost models of double wall factory built. So the unattractive look again of the traditional way of doing things. So foil face grease duct, not very protective, and of course not that pretty to look at. So ultimate materials, we've got copper outer there. I've got some painted stacks here. These weren't grease ducts, but they were boiler exhaust. Most of them are all boiler exhaust, I think. So, but we actually did a copper wall, about 100 foot worth here, copper outer. So, and then the pre-painted ones on the right-hand side.
We got
some company logos. Yep.
That's all right. We have another question from one of the engineers. So if we have a 4-story building construction, do we need the access doors every floor if we're using a factory-built grease duct? Okay,
so that gets back to a question earlier about the door spacing. So the code requires, basically, the way I interpret it is if your duct is not 20 inches, I think it's like 20 by 20, but say it's just 20 inches round. If you're smaller than 20 inches round, then they deem that as not large enough for personal entry. So NFPA / UMC / probably CMC is going to state that they're going to want an access door every floor if you have smaller ductwork, versus if it was large enough, call it 20 inches and larger, you in theory could apply the rule of personal entry as allowed. Granted, they would probably just clean it from the top and or bottom and reach down where they need to reach down. So, but that's kind of how the language reads. So it's basically, when I'm reading NFPA right now, on vertical ductwork where personal entry is possible, access shall be provided at the top of the vertical riser to accommodate descent. Where personal entry is not possible, adequate access for cleaning shall be provided on each floor. So that's kind of how it leaves it. And how that personal entry size comes into play, it basically, like on horizontal ductwork, it says, but I think it's tied into all of it. It's a 20 by 20 inches where how they kind of deem that size.
Okay, one more.
So hopefully that answers your question. Yeah.
Yeah, I think that does. Another question coming in here. On the average, what is the additional cost for the colored duct or some of the other things that you're showing there?
Well, it's case by case because it's based on size. And I think the painted option, it's powder coat painting, I think that comes in, let's just call it, and don't hold me to it, but call it maybe $7 a square foot on the surface area, based on the OD part. The copper, I cannot recall on that one. That one might be almost a double cost on the traditional baseline model price, if I remember. So, but the paint one's done by a square foot basis, and I want to say it was under 10. I'm pretty certain it was under $10 a square foot. But I think some of the requirement is you've got the cost of buying the paint as well, because every time you go buy a paint, you got to buy the paint vendor's minimum, bucket amount, call it, no matter what. So we have that initial charge, which could be several $100 on top of the square foot process to paint it and package it and stuff. So, but would be glad to do an example price out for somebody if they've got something on the works. We could definitely run some numbers for it. So,
thank you.
Yep. Again, so logos, and that's even a further cost, but can be done. As you see here, we did a copper sample on this one with a pretty intricate logo. So we do get pretty detailed with that. Fire safety. So this gives some pictures of what's going on during the test. This is ramping up to that 2,000 degrees on the internal grease duct testing. Again, same pipe that's used for the 1,000 degree and 1,400 degree chimneys, chimney exhaust that we have. So, but just kind of showing you the ability to go to those temperatures. And then the fire engulfment side, that whole assembly on the left, that gets dropped into a big furnace and gets engulfed with flames for 2 hours. And that's a typical building construction standard that's done to. And then on the outside, the top side of that cement slab is a exhaust fan tied to our ductwork, and then we got thermocouples measuring the unexposed side. So it's kind of to replicate the next dwelling space above where you'd have a fire going on below type thing, and so it's not passing flames through that. And then, as I said earlier, that whole duct segment is under a negative, and then once the 2 hours is up, that whole assembly with the duct, it's got to still be intact, and then that gets carried over, and then they do a fire hose test, as in to replicate a fireman coming into that room that's on fire, blasting water everywhere and making sure his water doesn't blast through a hole to the next floor up or room over, which unfortunately would, if that were to happen, that would allow flame propagation into those next rooms, and that's what we have to resist against. So coming into where the rubber hits the road here. So factory built systems before and after that 2,000 degree test, and then field welded ducts before and after that 2,000 degree test. So we did this long ago. When we did this testing, this goes back to early 2000s when we were doing this. And this was just something we had to show. I mean, this just goes to show you that these things, the field minimum requirements do not resist the 2,000 degrees like we're supposed to on the factory built side. So I said earlier, the testing for the wraps does not require there's no minimum collapse, or I should say maximum collapse requirement. So they are allowed to put on an upside down frown, I'll call it, and still be compliant. and or the flame propagation that we were talking about. So not quite apples to apples, but it is what it is in my mind. This is some pictures we got from establishment in Carolina. Carolina's obviously a severe grease fire here. The duct imploded, just ripped this thing to pieces here. And this was just a few select pictures of what happened. I mean, huge fire going on there, probably a vacuum situation, and just caused this duct to do damage. And so just think of the demolition work tied to this. Had they had factory built system in here, chances are I don't know how much fuel was in there waiting, but chances are you'd only have a few duct sections to swap out with a factory built system, and modular at that. Really probably wouldn't need welding to come in. Just put in new ducts and V-bands. But this situation here with the welded steel, that's just a whole lot of demo work and downtime for that restaurant. So UL fact-finding report just kind of talks, again, some research they did on just the highlight is that 7 inches of deformation due to the internal heat that the wraps did with the rectangular steel. Too much heat for the carbon steel rectangular shape, basically. So when it comes to temperature and strength, your austenitic grades of stainless, 304 or 316. By default, we use 304. Just much higher strength ability than carbon steel, as you can see there lower on the chart, as the temperature elevates. So stainless holds its strength much better than carbon steel, and so does a round shape versus a rectangular. Some costing, RS Means, a little bit older test, or a little bit slightly older book, but did some costing on just pipe for pipe type thing. A Z3 model, 304 aluminized, about $390 a foot for a 24-inch diameter, using a 3.5 foot long pipe price. We actually can offer 5-footers now up to a 26-inch OD equivalent. So for a Z3 model, that would put us at a 20-inch ID maximum to have a 5-foot length offering. So I think when I did this costing, we didn't have 5-footers available, but so we have expanded that a little bit. And then $190 a foot for a 12-inch diameter. Carbon steel ends up being pretty much about the same, welded basic 2-layer duct wrap. And then the non-fire rated and non-zero clearance. So our traditional models, we'll call it non-fire rated, non-zero, 1-inch blanket, 2-inch blanket, much less cost tied to those two. So also take note, field wrapped and welded ducts, 24 inches to 48 inches wide, 2 foot to 4 foot wide, require weld pinning on the bottom side of the duct in addition to the regular steel banding. So that is a general requirement on the wraps. So that's additional labor. And I think vertical ducts need weld pins on at least one side. So just kind of tailing up here, obviously a lot of encouragement from the industry, ASHRAE associations, journals, handbooks, all speak to factory built systems and kind of encourage them as much as possible. Let's see, another cost example here. There's a lot of vertical here, but we were actually a little bit less. Site delivery cost was a few $1,000s less than what it would have been. Now, granted, this is a lot of vertical, so that's more beneficial usually in the vertical for stack than it is horizontally. Usually about a wash for an experienced labor for horizontal duct installation, and then vertical we usually gain a lot more benefit there. So a long list of things. I'm going to wrap things up here so we can get into some other questions. UL listed hoods. We use UL listed hoods and fans, so encouraging to try and start using more UL listed factory built duct as well from beginning to end. So call it the missing link. And then my joke of the day, new meaning of telephone support. Please don't do that out in the field. So I don't know what the tensile strength is on that phone cord, but probably not enough to support our duct. So, but that was a real live situation. All right, all the other applications, boilers, pizza ovens, roasters, commercial dishwashers, multi-appliance with subduct risers, cogeneration, generators, I think I said. So lots of different applications that our products are used on. And there we go. So Q&A. Anything left? 10 after here?
We had a question coming from the engineer just asking what's the standard time frame for factory built grease duct. I mean, I think it's still the standard 10 to 15 days, right, Keith, unless it's custom or?
Yeah, no, that's so after layout, the design layouts all agree, and DB Sales can elaborate more on that. Obviously, there's back and forth that happens with getting a design layout schematic done with our design group. But after all the dust settles there and clarified, and you get your bill of material list to work from, and the order is in, that is a good statement. 10 to 15 days. Usually, there's a couple days of booking process. Basically, once the order is booked and sent back to DB Sales, that's a couple day lag usually, and then usually it's a 10-day clock after that. So, but 10 to 15 days is a good
usually working time to just so everybody out there. Yeah, working day.
We do have some quick ship options available. It depends, that ebbs and flows based on load, but usually our factory in Idaho is pretty good with that. And there's limitations to the quantity of parts with that quick ship, but and of course there's a premium tied to that, but we can do a 5-day build. I think there's a 5-day and a 7-day build option for those. So.
We got another question coming in here from Matt. Can I start a system at a hood with C1/C2 and then change to Z3/Z4 before passing through a 2-hour separation? And if so, is there a minimum distance of Z3/4 before passing through the wall?
Good question. The way I interpret the code and have been promoting that for years is that, yes, once you leave the appliance zone, that's a rated wall or floor, that's when you need to transition to Zebra 3, call it. So you could even use, in my mind, single wall in that hood space, assuming you have clearances for 18 inches on the single wall, or like you said, the C1 or C2. As far as what distance there is, that's not really specified. So I would, it'd probably be a longer length of pipe passing through the wall is what I would suggest. Then you've got our fire stop that would be required there at the wall or floor with the Z3. So obviously the Z3 would have to be, a portion of it would have to be on the appliance side where you have the C1, C2 going on. But there's not really a set distance that I don't think code requires and that we require. So, like I said, good practice would just say if you can accommodate a couple feet worth or a longer length of pipe, that would probably be the best way if possible. So.
Okay, thank you, Keith. I don't see any other questions coming in here, and I know we're probably a little over time here, but thank you very much, the Keith and the AMPCO team here today for coming and sharing and educating us on some of their products and design guidelines and information. So if there are any other questions, let us know now. Otherwise, thank you again. Thank you everybody for attending.
Thank you. Appreciate it. Have a good day.